In chemistry, we're typically interested in the electrons in a compound because it's the electrons which are holding the atoms together in bonds. And chemical reactions involve breaking bonds and making new bonds, but we always have the same number and types of atoms. They're simply rearranging. That's not true in nuclear chemistry. In nuclear reactions, we're actually changing the nucleus of the atoms. And because the type of atom, whether it's helium or xenon or carbon, depends on the number of protons, if we change that number, then we change the kind of atom that it is. And in nuclear chemistry, that's exactly what happens. We have different types of nuclear reactions. We have reactions which involve nuclei splitting up and one atom forming multiple atoms. Those are called fission reactions. We also have fusion reactions, where multiple nuclei come together and make a single atom. And then we also have just nuclear decay process, where one atom spontaneously converts into a different type of atom by spitting out a small subatomic particle. All of these changes involve massive changes in energy. Energy changes which are tens or hundreds of thousands of times larger than in a typical chemical reaction. Because these energy changes are so big, we actually get a measurable change in the mass between the products and the reactants in the reaction. And that's because mass and energy are related by the theory of relativity. And so nuclear reactions don't conserve the mass, where we typically say chemical reactions do. And this is a big difference between traditional chemistry, where the atoms are always conserved, and nuclear chemistry, where the atoms change their type.
Radioactivity is also radioactive. In both chemical reactions and nuclear reactions, atoms become more constant. This means it is not likely to change. In a chemical reaction, atoms tend to attain a more stable electron configuration by transferring or sharing electrons. Nuclear reactions begin with unstoppable isotopes or radioisotopes. Atoms of these isotopes become more stable when changes occur in their nuclei. The changes are always accompanied by the emission of large amounts of energy.